Hi, this is Andy Neff with Neff Automation. I'm the sales team leader down in Kentucky.
And I'm Doug Grogg. I'm one of the technical sales rep down in Kentucky.
So we want to talk to you a little bit today about what we see commonly out in the field from a pneumatic perspective as far as valving going to cylinders here. We've got a quick little demo to show you. This is a 92 series from Mac Valves, about a 1.2 CV worth of flow, connected up to a 25 millimeter bore by 75 millimeter stroke from PhD. This is their CV cylinder, both very high performance valves and cylinders in the marketplace. But what we commonly see out there, and you've probably seen it as well, is we have a bank of valves that looks just like this, and it might be going out to a machine, and you might have anywhere from a 10-foot to 15-foot run of tubing, and we commonly get asked how we can improve the speed, and we've got a couple of ideas. Oftentimes we hear pressure, but I'm sure you probably have a better idea of what can really make that impact.
Yeah, so a big thing is just the length of tubing, right? So a lot of times when you want to go faster, it's length of tubing, size of valves, right? That's going to get your cylinders moving faster. And Andy's right. Most of the time we go out there, machine, your valve stack is on the outside of the machine, and for good reason, right? You want to be able to easily access it. But sometimes performance necessitates some type of adjustment to that.
Yep.
And so that's what we're here to talk about, is how do we optimize our system a little bit more. And a simple change is just by moving the valves closer to the action.
Yep.
So that's why we're just going to quickly show you.
We've got a couple different setups here. This is 2 feet of tube, and then we're also going to test it with 10 feet of tube as well. We are also going to do 40 PSI and 80 PSI pressure just to see what the difference is.
We've got the 2 sensors, end-of-stroke sensors, that's going to be, as soon as we push this button, it's just going to be operating it back and forth. Once it hits the end of stroke, it'll come back the other way. And we'll see how many cycles we can get in 15 seconds.
Yep. So 15 seconds there. How many strokes did we capture there?
Looks like 83 cycles.
Okay.
Yep.
So now we're gonna change this up. We're gonna go to 10 feet of tube here, and we're gonna stick with 40 PSI.
.45.
As you look at an application like this, how much has history told you that pressure impacts the speed at which a cylinder like this would operate?
Well, it's like initially you'd think like, oh, I just turn up the pressure and there's going to be more force that's going to make it go faster. But and sometimes it can seem that way because of how a cylinder might start a little bit, getting past that friction. But ultimately, it's the flow. I mean, the flow is speed.
Yep.
Increase your air pressure. I mean, that's your force.
Yep.
Pressure equals force. Your flow equals your speed. So yeah, time and time again, we're up against it, and so that's what we're going to show, is that that tubing affects a lot more than the pressure difference. So
yep.
It'll be fun.
Excellent. Well, we're gonna let this rip here. Same setup as before. Single solenoid. We're gonna let this thing run for 15 seconds, full end of stroke, and we're performing this one at 80 psi. So we're gonna see how a 40 psi differential is going to impact the speed of stroke here.
Roll. .59.
Okay, so
59 cycles.
So now we are going to 2 feet of tube, and just by making this simple change, getting the valves closer to the actuator, we're going to see how much this impacts the stroke length here. So still at 80 psi?
Still at 80 psi? All right. So 93 cycles.
So it was what, 50?
So 59 to
90.
93 cycles.
Wow, almost doubling the rate that the amount of strokes that we got
Yeah.
there. So pretty impressive. So if you're looking for more tips like this on how to improve pneumatic performance, get faster cycle speeds, let your local Neff representative know. Call your Neff office or go online to neffautomation.com and let us know how we can help you.
Thanks for watching.
Thanks.